Good morning, sir. This is Hasika from CAD A section. Today, my topic is on theory of Newton's rings. What are Newton's rings? Newton's rings are concentric circular interference fringes formed when light is reflected between a spherical surface and an adjacent flat surface. It is discovered and investigated by Sir Isaac Newton in the 1660s. It is observed with monochromatic light as alternating dark and bright rings. It is a classic demonstration of thin film interference and wave nature of light. The central spot is typically dark in reflected light. Link spacing decreases with distance from center. Physical phenomenon. Newton's rings occur due to thin film interference in the air layer between a curved lens and a flat plate. Air film between a plano-convex lens and flat glass plate acts as a thin film of varying thickness. Thickness increases with distance from the contact point. Light waves reflected from top and bottom surfaces of the air film interfere. Circular symmetry arises from the spherical curvature of the lens. Path difference determines constructive bright or destructive dark interference. Optical path difference delta is equals to 2t plus lambda by 2. Now let us have a look at the experimental setup. The apparatus consists of these essential components: monochromatic light source or sodium lamp for uniform wavelength, plano-convex lens with large radius of curvature, optically flat glass plate, 45 degrees glass beam splitter to view reflected pattern, traveling microscope for precise measurement. Light from the source passes through the beam splitter and illuminates the lens plate system nearly perpendicular to the surface. The interference pattern can be observed and measured from the above. Newton's rings form due to interference between two reflected light rays. Ray 1 reflected from the curved lens air interface. Ray 2 reflected from the air glass plate interface. Phase change of pi occurs upon reflection at the higher index boundary. Path difference depends on the thickness T of the air film at radius r. The optical phase difference between rays is given by delta pi is equals to 4 pi mu t by lambda plus pi. Now the interference conditions of the reflected light. Dark rings are formed due to destructive interference. The condition 2t is equals to m lambda, m is equals to 0, 1, 2. The center is dark, m is equals to 0 because of a pi phase shift upon reflection at the upper surface when t is equals to 0. Bright rings are formed due to constructive interference. 2t is equals to 2m minus 1 into lambda by 2 where m is equals to 1, 2. For bright rings, the path difference must offset the initial pi phase shift. Let us discuss about the radius and diameter formula for dark rings. Step 1 is interference condition. For dark rings, destructive interference 2 mu t is equals to m lambda. Step 2 is we substitute the film thickness. Step 3 is to solve for radius and step 4 for diameter formula. Radius and diameter formula for bright rings. Step 1 interference condition for bright rings. Step 2 substitute film thickness. Step 3 solve for radius. Step 4 diameter formula. Newton's rings have several important practical applications in optics. Wavelength determination. By measuring ring diameters and known radius of curvature, the wavelength of monochromatic light can be precisely determined. Radius of curvature measurement for lenses and curved optical elements when the wavelength is known. Surface testing. Deviations from perfect circularity in the ring pattern reveal surface imperfections and irregularities. Optical flat testing. when used with optical flats, produces straight line fringes to check flatness diffractive index measurement by replacing the air film with the liquid and observing the contraction of rings. Film thickness measurement. Transparent films can be measured with nanometer precision. These applications make Newton's rings an important tool in optical metrology and quality control. Key characteristics and notable observations. Center is dark in reflected light due to pi phase reversal at t is equals to 0. Ring spacing decreases with increasing radius following the relation. Dependence on wavelength. Shorter wavelength produces closer rings. White light creates colored fringes. Effect of medium. Rings shrink by factor 1 by root mu when air is replaced by a liquid of refractive index mu. Diameters of rings are proportional to square roots of natural numbers. Deviations from perfect circularity indicate surface imperfections. Thank you.